Hello everybody, this is Milad, and in this tutorial I want to teach you how to implement a neural network using Python and TensorFlow. Well, before jumping into the code, it is necessary to understand some basics regarding artificial neural networks. There is an important question, and that is, what is deep learning exactly? Is there any difference between artificial neural networks and deep learning, or it's just a conceptual misunderstanding? Well, to answer the question, just look at the flowchart here. As you can see, artificial intelligence, or AI, is a general area referring to the developments and technologies that give machines the ability to think and decide. Machine learning is an area in AI that consists of various methods and algorithms, mostly for building mathematical model of sample data. One of the most important and effective methods in machine learning is artificial neural networks. And finally, as you notice, deep learning is just a name for a specific type of neural networks. Well, consider the neural network on the left side of the image. It consists of an input layer, an output layer, and only one hidden layer. We call it a non-feed-forward neural network. If we want to turn this feed-forward neural network to a deep neural network presented on the right side, all we need to do is to increase the number of hidden layers. Increasing the number of hidden layers gives the ability to the network to extract and capture more prominent and distinctive features from the input data, and ignore the variations in, for example, a scale, light, or angle. Another example for deep learning is convolutional neural network. When convolutional neural network was presented for the first time, it was very simple, including one sampling layer and one convolutional layer. Later on, increasing the number of hidden layers turned it into a deep neural network which can extract more prominent and more important features from the image for a specific category. As I mentioned before, in this video, I'm gonna implement a simple feed-forward neural network to classify numbers. And there is a very popular image dataset called MNIST, including various numbers ranged from 0 to 9. And we're gonna use it to feed the neural network and train the model, and then use the trained model to identify a number. But before proceeding any further, let me explain our model in detail. Considering that in this example we're going to use a feed-forward neural network to classify numbers, it is necessary to convert the two-dimensional input data into a one-dimensional vector before feeding it to the model. This input layer is known as flattened layer in TensorFlow. The next step is adding a hidden layer to the model. There are different types of hidden layer in TensorFlow, but one of the most important one is a fully connected layer, which is also known as dense layer. A dense layer or fully connected layer is a layer in which each neuron is connected to all pixels of the input data. We can have as many hidden layers as we want, but the number of hidden layers and the number of neurons in these layers are highly dependent on the complexity of the input data. And finally, the last layer is output layer. The most important thing here is the number of neurons in the output layer. And the number of neurons in the last layer are determined by the number of categories of input data. We're going to use MNIST dataset here. In this dataset, the numbers are ranged from 0 to 9. So we're going to have 10 neurons in the last layer. Okay, it's time to code. First, open the command window and type Spyder 3 to open a Spyder IDE. Well, as you know, Spyder is a very powerful IDE for data science tasks, so I highly recommend it to you for coding. Okay, let's import some libraries. First thing we need to import is a TensorFlow, so import TensorFlow as TF. Then keras from TensorFlow. Import keras. And the next step is to import MNIST dataset. So we type MNIST from keras datasets, and let me show you something useful before importing the datasets. The Spyder IDE doesn't have any suggestion tool by itself, so we need to install a complementary package called rope to make suggestions for you. Okay. Go to the command window and type pip install rope, if I'm not mistaken. Let's search about it. Open the web browser and type rope for Spyder. Yep. Let's see why I can't find this. Let's change it to install rope for Spyder. Okay. Well, here it is. Pip install rope. So pip install rope. It's probably gonna be installed on my machine, so it says requirements already satisfied. But probably if the module isn't installed on your Windows, it probably shows a different message. Well, and to use rope, you need to restart the Spyder IDE and keep Control key down and press the space key to show you the suggestions for a specific module. Okay, the structure of returning data of MNIST dataset is as follows: xtrain, ytrain, xtest, and y-test. X-train, y-train, x-test, and y-test. Okay, mnist, that's load data. For the first time, it's going to download the data from the web, but for future uses, it won't take long to load the data. Okay, let's run it and see what happens. Well, let's do some digging. Well, as I said before, Spyder is a very useful and powerful IDE, and it's mainly because it gives you the ability to search around for different variables and their properties, such as type and size and shape. There is an area in Spyder IDE called Variable Explorer, in which all variables are listed with their properties. As you can see, the size of the x-test data. Okay, let's see the content of y-test. As you can see, the numbers are ranged between 0 to 9. It actually shows us the number of categories. Let's have a look at x-test data and see the first image by double click on it. As you understood, it shows the number of 7, and the values are between 0 and 255. So we need to normalize the data by dividing it to 255. We do it for both x-train and x-test. Well, 250. Okay, it's fine. Let's show one of the images of x-test data using matplotlib pyplot. Import matplotlib pyplot splt, I believe. Pyplot splt. Okay, plt.imshow. We try x-train, first image in the x-train. Okay, and plt.show. Okay, run the program, and what you see is let's change the number of image. Show the fourth image. Okay, I believe it's 9. Try 14. Well, the 14th image is the number 1. Change the color map to gray using CMP attribute. Okay, well, it's in gray. That's fine. Okay, just comment them because we don't need them right now. The next thing is to define the model type. Now, there are a few types of model in TensorFlow, and one of the most important one that we're going to use is sequential type, because we're going to use different hidden layers, input layer and output layer. All the layers are in sequential order. There is a layer after another. So we use cross.models.sequential. The next thing to do is to add different layers to the model by using the method of add. Model.add. So the type of first layer is flatten, because we're going to convert the two-dimensional image into a one-dimensional vector. We use flatten layer, cross.layers.flatten. Okay, the next layer is a fully connected layer. Model.add cross.layers.dense. Well, there are a few parameters we need to specify for the layer. The first one is the number of neurons in the layer. So we use 100 neurons in this example. The next thing is the activation function. We need to determine the type of activation function. There are different types of activation function. One of them is rectilinear linear unit. This activation function filter the negative numbers and let the positive numbers pass as they are without doing any calculation on them. Another activation function in TensorFlow is softmax. Let's explain it later. First, define the activation function for this layer, which is using rectilinear linear unit called RELU. Okay. Well, let's add the output layer without make the neural network deep. Just a simple feed-forward neural network is enough, I believe. Model.add cross.layers. For the last layer, 10 neurons would be enough because we've got only 10 categories. Activation function would be softmax. Well, let's explain softmax activation a little bit. Softmax activation function takes unnormalized numbers and normalize them by converting them into a probability distribution between 0 to 1. And also you can see the function of softmax. It's the relation between input and output here. To add it to the model, we use softmax keyboard for the activation attribute. Okay, before using the model, we need to compile the model by some parameters, including loss function, the optimizer algorithm, and some matrices that we want to show during training. An optimizer is a method by which we minimize the loss function or cost function, and a cost function is a relation, a formula between the desired output and the actual output. And actually the neural network tries to minimize the difference between the desired output and the actual output by minimizing the cost function. The algorithm here we're using is Adam, and so for cost function we use because we have 10 categories and we want to classify different numbers, we're gonna use a sparse categorical cross entropy as cost function. Well, sparse categorical cross entropy. Okay. And the final thing is matrices. Actually, matrices will be shown during the training model. So we use accuracy here to show the accuracy. The final step is to train the model by fit method. So type model.fit. Xtrain as the train data and ytrain as the labels for the train data, and let's define the number of epochs. Okay, it's time to test the program and run it. Okay, well, everything's working fine and it's awesome. The accuracy, as you can see, is 91% in the first epoch, and in the last epoch it's 97%, which is a very good accuracy. So our neural network works fine, just with one hidden layer. The next step after training the model is to validate the model by using evaluate method and pass the test data into the validate function. It returns two variables called val loss and val accuracy, and a model that evaluates x test and y test. Okay, let's run this line and see what happens. Okay, select the line and click on the black button of run. Well, let's print the results. Print val underline loss and val underline accuracy. Well, okay, as you can see, the accuracy is 97%, which is a very efficient result and shows that the model works fine. The performance is high for classification of numbers. Let's play with the parameters of the model and see what happens. As mentioned before, we can add another hidden layer to the model. So copy this line and paste it as it is. Okay, and run the program to see what happens. Is it gonna improve the model or not? Wait to see the accuracy value. Okay, the accuracy is about 97%. It's the same as it was, so adding another hidden layer didn't improve the model significantly. So far we have designed the model, trained it and validated it, yet we haven't used it to predict a number. So to use the model for prediction, there's a method called predict. Okay, just type model.predict and we pass the X-test data as the input. Let's run the program and see the results. Okay, double click on predictions. As you can see, it's a matrix that it has 10 columns as the number of categories, and each row is related to an image in the data set. So to identify the correspondent category for each image, we need to select the maximum value in each row. As a matter of fact, the values are resulted from the softmax activation function, so it's a probability distribution between 0 to 1. So we need to select the higher one as the predicted category. Back to the program. There are different ways to take maximum, but we prefer to use argmax in NumPy package. So import NumPy as np okay, and let's use argmax. Let's import. Okay. Well, output class np.argmax x-test. We're gonna pass the first row. Okay, and let's result. I believe something's wrong here. What's the problem? The values. Oops, we need to pass predictions, not X-test actually. Okay, predictions. Run it again. So, as you can see, the output class is 7, and to make sure of it, let's print the first image in the test data set. Just copy the 2 lines and change it to X-test, and okay, change it to 0 and run it again. Okay, well, it's working. As you can see, the predicted category is correct, and it shows 7. Okay, I believe that's enough for this tutorial. Thank you for watching this video. I wish the best for you.